Hey guys, Mr. Gucci here with his lab help video. All right, I'm going to take you through how this lab is supposed to work today. So, what we're going to do is we are going to calculate the frequency and the energy of specific light wavelengths that are emitted by gases. Okay, we're basically redoing Niels Bohr's experiments with hydrogen, but using different elements. So in here, you're going to be doing three different types of math, all right, that we've covered in this unit. You're going to be taking nanometer wavelengths and converting them into meters. You're going to be taking meter wavelengths and calculating the frequency, okay? And then you're going to be using the frequency to calculate the energy, like we were doing on homeworks today, okay? So you're going to start off by answering some questions, yada, yada, yada. And then you're going to get to some of these things right here where I show you the emission spectrum of different elements, and I have you calculate some different factors about them. So let's take a look at this one right here. Okay, this is number 2 from your lab. Number 2 is, in this case of this is the emission spectrum of neon. So if you shine neon light through a prism, all right, you are going to see all these colors appear. A whole bunch of red and orange and yellow, which is why neon light glows mostly orange, but a little bit of green and a little bit of blue and purple as well. All right, it will tell you in this problem, calculate the wavelength, the frequency, and the energy of the shortest green line in this neon, okay? So in this case, the shortest green line is about here. It's about 500 nanometers, 510, 520, okay? So you would say, okay, we're going to start by taking 520 nanometers, and we are going to convert that into meters, okay? So that's going to be the first problem that you have to do here. Now, I'm not going to solve this problem for you, okay? I'm not going to do it for you. Instead, I'm just going to pretend that this problem was slightly differently phrased, and I'm going to ask you all to calculate the wavelength, frequency, and energy of the shortest blue line. Okay, this is just my sample here. I'm going to show you how this goes, okay? Shortest blue line. Now, the shortest blue line is over here, okay? The shortest blue line is like over here. So what would that wavelength of that short blue line be in this slightly different sample problem? Well, this is 450 nanometers. One line over is 460, and this is like halfway between 460 and 470, a bit closer to 460. So I'm going to call this 464 nanometers, and I have got to convert that into meters, okay? Now, how am I going to do this? If you go back to your homework, you might recall that to get from nanometers into meters, you divide by 1 billion. So 464 nanometers divided by, and all this math is such that you could probably type it up in here to show your work. If you don't want to show your work here, you can attach it on a separate sheet. 464 nanometers divided by 1 billion. All right, and what you get is 4.64 times 10 to the -7th meters. Okay, I can actually take this -7 and I can go to Format, Text, Superscript. There we go. Oopsie, I messed that up. That's okay. We all understand. We're all forgiving here. All right, here we go. Let me redo that. Superscript. Oh my God. Text. Oh my God. Why are you so dumb, Google? Did this just freeze? Oh my God. Computer issued laptops, everyone. School issued laptops. Oh my God. Okay, here we go. Yes, there we go. Which is why, guys, it's sometimes easier just to write 4.64 e -7, all right, meters, right? This is why I've totally approved of using the e thing right there. Okay, cool. So that is how you get the wavelength. Take the nanometer measurement, divide by 1,000,000,000. Next step, okay? You have to figure out the frequency. So the frequency is just the speed of light equals the wavelength times the frequency, all right? Okay, cool. So we know the speed of light because the speed of light is a constant. It does not change. We know the wavelength in meters because we just solved it up above. All right, we know what it is. It's 4.64 times 10 to the negative 7th. And now we have to find the frequency. The frequency. So here we go. The speed of light equals 3.00 times 10 raised to the 8th meters per second. Okay? And that is going to be equal to the wavelength, which up above here, the wavelength is 4.64 times 10 raised to the negative 7th meters. And that's going to be times the frequency. So we're looking for this frequency. Let me make sure all the colors line up. All right. So here we go. We're just calculating the frequency now. Now I'm going to pause this real quick and I'm going to come back to it. Class is restarting. I can hear you all chiming in. As soon as I dismiss, I'm going to finish recording this video. All right. And then I'll post it. All right, getting back to this. Sorry, I was temporarily had to go away. So we are trying to find the frequency in this equation right here. Okay, we have to get f by itself. We have to solve for frequency. And that means that we have to divide both sides by this wavelength. So I'm going to try and get creative here using some formatting. If you want to try and do this, or if you want to just write this up on a separate sheet and attach it, that is also acceptable. Okay, so we have to divide both sides by 4. Let's copy it. 4.64 times 10 to the negative 7. Dividing both sides by 4.64 times 10 to the negative 7th. Okay, and what that's going to do is that's going to cause it to cancel out over here. All right, so it's going to cancel out over here. And on this side, we are going to get frequency equals 3 times 10 to the 8th divided by 4.64 times 10 to the 7th. Now, here's how I would do the math on this. What I would do is I would just open up another Google search bar, and I would do 3.00 times 10 to the 8th divided by 4.64 times 10 to the negative 7th. All right, and I would use E values instead of doing the times 10 raised to the. Using E is just much easier on a computer or calculator. And so I get 6.465, so that would be round up, that would 6.47 times 10 to the 14th hertz. All right, 6.47. The frequency equals 4.67 times 10 to the 14th hertz. Okay, there we go. So now we have the frequency. In fact, let me put this in like official scientific notation method. All right, here we go. Format, text. In case you guys forgot, using E is just another way of writing times 10 raised to the. All right, so that is the frequency. Now we've found the frequency. The last step is they want you to find the energy of this photon of energy, of electromagnetic radiation. So the energy equals the frequency times Planck's constant. Okay? So the energy is going to be equal to the frequency, which we just solved above. All right? It's the exact same frequency. So the frequency, you can even copy and paste it if you want. Save yourself some time, guys. All right? So it's going to be the frequency, which is 4.47 times 10 to the 14th hertz, times Planck's constant, which is a constant. All right, Planck's constant is 6.63 times 10 to the negative 34th. All right, so that is Planck's constant. This is definitely one that you guys could just type in here. Okay, so let's see. What does that equal? Format text. So what does that equal? Once again, I'm just going to go into Google and I'm going to type this in there. I'm going to 4.47 times 10 to the 14th times Planck's constant. So once again, I'm just going to go into Google. I'm going to do 4.47 times 10 to the 14th times 6.63 times 10 to the negative 34th. And what I get as my answer is 2.96 times 10 to the negative 19. So 2.96361, I just want those first decimals. So 2.96 times 10 to the negative 19th. All right, so the energy here is 2.96 times 10 to the negative 19th joules. The unit here is joules. If you want to use E instead of the times 10 and raised to the, you could do that as well. So you could just go E equals 2.96 E negative 19 joules. Either one of those is acceptable. And that's how you find the energy. Okay? So there you go. Let me highlight these guys. And I don't know, what's an energetic color? We already did yellow. Purple? Purple's cool. All right, cool. So there you go. So those are the steps, folks. You have to start by taking the nanometers and convert into meters by dividing by a billion. All right? Divide by 1 billion, or 1 times 10 to the ninth. All right? That's the first step. Next, once you got your wavelength, you got to plug in the wavelength to get the frequency. All right, cool. Lastly, once you solve the frequency, you are going to need to use the frequency to get the energy. Okay? So that's what you have to do. Just 3 steps each problem. All right, guys, good luck. I hope this video helped. I'm going to now bounce around the breakout rooms and try and help you all out.